Welcome back, guys. Welcome back. Yes, we have taken a short break, right? We'll continue with the next session, which is 100 days challenge of physics. Yeah. So welcome, guys. Welcome you to NEET World. So in this session, we are going to focus on the top 100 topics in 100 days, which is in physics. So this will be for both JEE mains as well as the NEET. Wait a minute, I'll open the PPT. Yes. Okay. So let us start. Right. So the topic which we are going to see in today's session is Pascal's law, capillarity and viscosity. So these are the topics which we are going across in fluids, right? So Pascal's law, capillarity and viscosity. First we will see what is Pascal's law and what is capillarity and what is viscosity, the meaning of this. So first thing, Pascal's law. So pressure applied at any point is in a confined fluid is transmitted equally and undiminished in all direction throughout the fluid. So that's the meaning of the Pascal's law, right? So when I apply a pressure at one end, the other end also will be like give the same pressure, whether it area is different or same area or less or more, whatever it is. But they are saying the pressure applied at any point in a confined fluid is transmitted equally and undiminished in all direction throughout the fluid. Okay. So the second thing is capillarity, right? The ability of a liquid to flow in a narrow space without the assistance of external force. So this is the meaning of capillarity. The third thing is viscosity, the internal friction between the layer of a fluid that resists the motion. The same like which we have seen in kinematics, na friction. So the internal friction, obviously the friction only between the layers of a fluid that resists the motion. Okay, the meaning of Pascal's law, capillarity and viscosity. Now we go into the topic and we'll see what are the formulas are which we go across the fluid in these three topics, and let us solve some questions regarding these topics. So first thing, Pascal's law. So Pascal's law states that when pressure is applied to a confined fluid is transmitted equally and undiminished in all direction throughout the fluid. That's the thing we have seen. So the principle is the foundation of hydraulic system such as jacks and lift. So in the lift, in the lift we can use the Pascal's law. They are saying like if I apply some pressure in one end, the other end also will give the same pressure. Okay. So the mathematical formula, like we know the pressure is nothing but force by area, no? Force by area. So suppose if I consider, let me take a pen. If I consider this is my thing, no, like this is the working mechanism. Let me consider. So suppose this is the one end and this another end. Okay, in A, I mean one end of A, B. I mean one end is A and another end is B. If I apply some pressure here, no, like P1, the equal amount of pressure should be given in the side of B, right, in the side of B. So what is the pressure formula? P is equals to force by area, no. So what is P1? P1 is equals to F1 by A1. What about P2? F2 by A2. So should be equal, no, it is equals to F2 by A2. So I can say the formula, no, F1 by A1. F1 by A1 should be equals to F2 by A2. I can use like this, na, like pressure at both ends are equal, P1 and P2. We know that pressure is nothing but force by area. So F1 by A1 and F2 by A2. So if I equate them, I will get F1 A1 I mean F1 by A1 equals to F2 by A2, that's it. Okay. So this shows that the small force is applied to a smaller area can result in the larger force at a larger area. It explains how hydraulic lift can raise heavy vehicle with minimal effort. Okay. So let me consider this is the vehicle standing here. If I apply some pressure here, no, the equal amount of pressure is raised here. Okay. That's the concept they are saying in the Pascal's law. Okay. So this is the formula, guys. We'll go for the next thing. The next one is capillarity. So capillarity is the phenomenon where a liquid rises or falls in a thin tube due to the surface tension and interaction with the tube's wall. Okay. If dipped in a water, the water rises forming a concave meniscus. Okay. If I dip it in the mercury, which does not wet the glass, water will wet the glass, but mercury will not wet the glass. The mercury is depressed form. So a convex meniscus forms in water, concave, in mercury convex. Please note that point: water concave one, mercury convex. Okay. So application of capillarity: oil rises in a lamp wick, ink rises in the nib of the pen, sap and water rises in the plant stem, towel absorbs water by wicking action, ink is absorbed by a blotting paper. So some examples are there. Okay. So if we need to know about the formulas, right? The main thing is formula. So capillarity rises, ascent formula. When a liquid wet the wall of a capillarity tube, it forms a concave due to the surface tension T. So there is an excess pressure. Yes, there will be an excess pressure. No. So pressure minus atmospheric pressure should be equal to 2T by R. So this is the thing. So the formula is, you can directly take the formula. H is equals to 2T cos theta by rho g R. How much height it has been raised? H is equals to 2T cos theta by rho g R. Okay, you have noted the formula, no? The next one is discussion of capillarity rise and depressions. So for a liquid that wet the glass or a capillarity tube, the angle contact is less than 90 degree. First point. So cos theta is positive, height is positive. Okay. So the liquid rises in the capillarity tube. Example: water, milk, kerosene, petrol, etc. For a liquid does not wet the glass or a capillarity tube, the angle of contact is greater than 90. So cos is negative. So height will be also negative. We have seen the formula, no? H is equals to 2T cos theta by rho g R. When angle is less than 90, height also positive. When angle is greater than 90, height is negative. Okay. So example is mercury. Okay. So whenever the question is asked in types of mercury, now you can directly say height will be obviously negative. So in case of water, milk, kerosene or petrol, the height will be positive because the angle is positive. So we'll go for the questions now. Okay. The first question is, in a hydraulic press, a force of 100 Newton is applied to a piston of an area 0.01 meter square. The area of the output piston is 0.5 meter square. What is the output force? So simply I can use the formula, no, like pressure, no. So F1 by A1 should be equals to F2 by A2. That's it. So what is the force they have said? Initially 100 Newton. 100 divided by the area is given 0.01 should be equals to F2 I need to find, which is divided by 0.5 meter square. The area they have given 0.5. So if I multiply this, if I take this 0.5 and if I multiply here, no, F2 will be equals to 100 into 0.5 divided by 0.01. So multiply and divide by 100. Okay, multiply and divide by 100 so that I can cancel this 0, no. So 100 into 0.5 into 100. Okay. So 1 0 and 1 0 will be cancelled out. So 1 2 3 5 zeros. So 5000 Newton, that's it. So see here, 100 Newton and 0.01 meter square. So in the area of 0.5 meter square, how much force it has been given? 5000 Newton. Okay, 5000 Newton. So this is the output force. Option C is the answer. We'll go for the next question. Only you need to know what is the formula we have studied, and whatever the question they are asking, apply the formula there. First write what are the given terms in the question, then see which formula you need to apply it. Okay, we'll go for the next question. Okay, a capillary tube of a radius r is dipped in water. The height of a water rises inversely proportional to. So inversely proportional to, it is 2r, no, rho g r, no, height is equals to 2t cos theta, right? Yeah, so we know that capillary rays, no, so height h is equals to 2t cos theta divided by rho g r. So what they are asking, inversely proportional to, so height should be inversely proportional to rho, height should be inversely proportional to g, height should be inversely proportional to r. So which are the given things here? They have given in terms of r, right? So r square, r cube, root r. So what is the answer? Option A is the answer. R is the answer. Can we go for the next question? Okay, a sphere is falling through a viscous fluid at terminal velocity. Which of the following forces balance? Okay, so can you give the answer for this question? Terminal velocity they are asking. No, terminal velocity. So terminal velocity in the sense, obviously, so one of the force is gravity, like it's trying to push. So another force is like in the fluid, no, in the fluid. So in the fluid, in the sense, one will be viscous and another will be opposing force, that is buoyancy force. So one force will be viscous force is there, one force is opposing force, and one is trying to push, that is gravity. So gravitational force, F gravitational should be equals to F viscous plus F buoyancy. Okay, so this is the equation. Option B is the answer. So viscous force should be equal to gravitational force. No, obviously buoyancy force is there. So buoyant force equals to gravitational. No, viscous also is there. So they are saying through a viscous fluid. No, through a viscous fluid. So I need to consider both the buoyancy and viscous. If they are saying a fluid, I can say like a buoyancy force and gravitational. But they are saying that both viscous as well as the buoyance. Okay. We'll go for the next one. Okay. The next question is, if the radius of a capillary tube is doubled, the radius of a liquid in it becomes half, double, 4 times, 1/4. Okay. First let me write what is the given equation for the capillary tube. Height is given as h is equals to 2t cos theta by rho g r, right? What they are saying, if a radius of a capillary tube is double, so r will be equals to 2r, no, r will be equals to 2r, 2 times r, no, so it is 2 times, r becomes 2 times. What will happen? H is directly inversely proportional to r is the given equation, like given term. So we know that if r becomes 2 times, h will become 1 by 2 times. So half of it, na? So half of it. So h will be equals to 1 by 2. That's it. Half. That's the answer. We'll go for the next question. Okay. Which of the following does not work based on Pascal's law? Hydraulic brake, hydraulic lift, mercury barometer, hydraulic press. We have studied that like Pascal's law used for hydraulics, na? Brake, lift, press. What about mercury barometer? Barometer. Mercury barometer is due to the pressure, due to the height of the mercury column. Okay. Mercury barometer works due to the pressure in the height of the mercury column. Okay. That's the thing. So, which is not work based on Pascal's law? Obviously, mercury barometer. Okay. That is the answer. So, the next question, the viscosity of a liquid increases with temperature, decreases with temperature, remains constant, becomes 0. Can you give answer for this question? Yes. So, decreases with temperature because there is no intermolecular force, na, viscous, na, there is no intermolecular force. So, it obviously decreases with temperature. The next one, capillary action helps in photosynthesis, transport of food, absorption of minerals, ascent of sap. Obviously, ascent of sap, right. So, these like last 3 questions we have seen theory based, no. So, keep in mind these things. The next one, terminal velocity is directly proportional to radius, radius square, radius cube, radius power 4. What is the answer? Yeah, obviously it is radius square. So, V is equals to 2r square into rho minus sigma g by 9 nu is the formula, no. So, obviously V is directly proportional to, where's the pen? Yeah, okay. V is directly proportional to r square. Okay. For the terminal velocity, the next question is, in hydraulic machine, if a pressure on a small piston is increased, what happened to the larger piston? So, pressure decreases, pressure remain unchanged, pressure increases, volume decreases. Obviously, it equal, no. In hydraulic machine, yeah, hydraulic machine in the sense one side pressure I am giving, equal pressure, no, like if pressure increases I can't say the Pascal's law equals, na, Pascal's law applicable. So, pressure decreases, no, pressure remains unchanged, pressure increases, no, volume decreases. So, pressure remains unchanged, like its equal pressure is applied. So, F1 by A1 should be equals to F2 by A2, right. So, the last question of the session is the SI unit of coefficient of viscosity. So, do this question as a homework and give answer in the comment boxes. Okay. Yeah. So, take this question as a homework and give answer in the comment boxes. We will check it. So, with this we will end this session. We will continue with the next session in the tomorrow's class, that is exactly 10:50 AM, that is JEE mains PYQs followed by the 100 days challenge. Okay. Until then, bye bye guys, bye bye.